everyone! Today we are going to present about application of derivative in real life. Our course code is FSPM0024 and our group name is 4Y4F. I'm Candice and my matrix number is F23SP5625 and these are my teammates. First, he's Pei-Yun. His matrix number is F23SP5664 and the second teammate is called Lao Wei-Yun. His matrix number is F23SP5246. And the last teammate is called Yao King Wei. His matrix number is F23SP5488. The derivative is a fundamental tool of calculus that quantifies the sensitivity of change of a function's output with respect to its input. The derivative of a function of a single variable at a chosen input value, when exists, is the slope of the tangent line to the graph of the function at a point. The tangent line is the best linear approximation of the function near that input value. For this reason, the derivative is often described as the instantaneous rate of change, the ratio of the instantaneous change in the dependent variable to that of the independent variable. The process of finding a derivative is called differentiation.
Today, I'm going to tell you a story. It was a cloudy day. Eddie decided to go to the fun fair by car. When he was on the way, he wondered, what is the velocity and acceleration of the car?
Let's say the distance between the house and fun fair is 70 km, and the equation of the displacement is s equal to 50t plus 3t squared, and the time taken is 1.3 hours. So how can we find the velocity and acceleration of the car? So first, we need to differentiate the equation of the displacement, which is s equal to 50t plus 3t squared, and we differentiate it and it becomes the equation of the velocity. So differentiate becomes 50 plus 60. So that is an equation of the velocity. So how can we find the velocity of the car? Just put the time taken, which is 1.3 hours, into an equation. So v equals to 50 plus 3 times 1.3, and it becomes 57.3 kilometer per hour. So that is a velocity of a car. And thus, how to find the acceleration of car? Just use the equation of the velocity and differentiate the equation, become the equation of the acceleration. So which is 6 is plus 1, so it's 6 kilometer per hour square. That is the acceleration of the car.
Soon, Eddie arrived at the fun fair and went to the roller coaster. When he was on the roller coaster, he think about what is the shortest vertical distance from the track to the ground level.
The diagram shows the front view of part of the track of a roller coaster in a miniature part. The curved part of the track of the roller coaster is represented by the equation y equals to 4 over 125x cubed minus 3 over 25x squared, with point O as the origin. Find the shortest vertical distance in m from the track to the ground level. So now we need to write down y from the question it's given. Now we need to do the first derivative to find the maximum and minimum point, and let the first derivative which dy dx equals to 0. And now we can see that we have got two answers, which is x equals to 5 over 2 or x equals to 0. And now we need to do the second derivative to find out whether which one is maximum or minimum point. So now we need to do the d to the dx squared first. So when x equals to 0, from the equation just now is given, we need to sub into the d2 by dx squared. And we can see that the answer is negative, so it is the maximum point. Now we need to sub in another value. So when x equals to 5/2, we can see that it's positive and it's the minimum point. And which is the point, the value that we need to use. So we sub in the x equals to 5/2 into the first that is given by the equation. So you can see here, which is the 3m and is below the point origin O, so we have the negative 1/4. And now we need to have the shortest distance, the shortest vertical distance from the track. So we need to minus the answer, which is 3 minus 1/4 and 2 and 3/4, which is 2.75 meters.
After a while, the weather is getting hotter, and Eddie started to sweat. Then he found a vending machine with his favorite Coca-Cola inside. He immediately bought a can of Coca-Cola to drink, and the can contains 330 ml of the Coca-Cola. He wondered, how big is an aluminum can?
So the thing is, a can of soda contains 330 ml of soda. What is the minimum quantity of aluminum required to package 330 ml of soda? So before we start doing the question, we need to highlight the important information. Like the surface area of a cylinder is A equal to 2 pi r square plus 2 pi r hash, and the volume of a cylinder is V equal to pi r square hash. So the soda can contain 330 ml of liquid, which is the volume of a cylinder is 330 cm3. So first we need to substitute V equal to 330 cm3 into the volume of a cylinder equation. So when we got h equal to 330 over pi r square, we need to substitute h into the equation of surface area of a cylinder, which is A equal to 2 pi r square plus 2 pi r h. So we got A equal to 2 pi r square plus 660 over r. So we need to do the first derivative, which is dA over dr, because we need to find the maximum and minimum point and let it equal to 0. So when we got the value of r, we need to do the second derivative, because we want to know the r is maximum point or minimum point. So when we substitute r into the second derivative equation, we got the value, which is 37.6 is positive value, so it is minimum point. So we know that r is minimum value, which is 3.75, and we need to substitute it into the equation of surface area. So we got the final answer, which is 264.4 cm squared. So it is the minimum quantity of aluminum required to package 330 ml of soda.
That day, Eddie was happy because all his questions were solved. In conclusion, when we want to find the maximum point and minimum point, we need to do derivative and let it equal to 0. Then, to determine whether it's maximum point or minimum point, we do the second derivative. If the answer is positive, means it is a minimum point. But if the answer is negative, means it is a maximum point.